Something about Michio Kaku's expression didn't sit right. This wasn't the confident, ever-curious physicist the world had grown used to. The man who could casually bend string theory and quantum mechanics into digestible narratives for television. This time, he hesitated. His voice wavered. His eyes lingered on a single image behind him, frozen, glowing on the large screen. And when he finally spoke, the room, packed with leading scientists, journalists, and space historians, fell into a silence so complete it felt physical, almost suffocating. The briefing was supposed to be routine. A presentation of new lunar observations collected by next-generation satellites equipped with quantum-enhanced sensors, capable of imaging beneath the moon's crust in ways previously thought impossible. Nothing more. Yet what unfolded in the next hour would send ripples through the scientific community, rewriting decades of lunar science and forcing a reconsideration of humanity's place in the cosmos. Because this wasn't just data. It was a confession. Kaku began with a revelation that immediately dismantled the conventional understanding of the moon. Using these advanced quantum imaging satellites, researchers had scanned its subsurface at resolutions orders of magnitude beyond anything attempted before. What they expected was fractured rock, lava tubes, pockets of regolith, mundane geological features consistent with an inert celestial body. What they found instead were vast, hollow chambers. Not a few, not small voids, they were immense. Some spanning hundreds of kilometers, carved with symmetry, arranged with repeating geometric precision. The sheer regularity and alignment of these cavities defied natural explanation. There were straight lines, mirrored arcs, nested spherical voids, a blueprint of organization entirely absent in any known lunar formation. Natural processes simply don't do that. Then came the thermal data. Sensors detected heat sources emanating from some of these cavities, localized and rhythmic. The temperatures fluctuated with a precise cadence, far too regular to be volcanic. There were patterns in the thermal emissions, cycles, pulsing intervals, even harmonics, almost as if the moon itself had been wired to produce a signal. The room shifted uncomfortably. Even for the most rational minds present, the implications were staggering. Something inside the moon was not just structured. It was active. Kaku let the silence hang before he displayed gravitational maps. Tiny anomalies that had been dismissed for decades suddenly snapped into clarity. High-resolution data from multiple independent agencies revealed an invisible lattice crisscrossing the moon from pole to pole. These gravitational irregularities perfectly aligned with the voids and reflective metallic regions detected in the radar scans. It was as though the moon's internal architecture was connected to an external function. The lattice acted like a framework, stabilizing the moon's mass distribution with precision that borders on intentional engineering. If this structure is operational, Kaku said, his voice barely above a whisper, then the moon may not just orbit Earth, it may influence it. The implications were staggering. Tides. Axial tilt. Geophysical stability. Long-term climate patterns. The moon may not merely accompany Earth, it may regulate it. And if that regulation is intentional, then the question arises, who built it? And for what purpose? The presentation then shifted from physics to mythology. Kaku displayed ancient texts and iconography, from Sumerian clay tablets to Mayan codices and Egyptian hieroglyphs. Each described a time when the moon was absent, then arrived, almost as a celestial teacher. Stories of nights without moon, of sky gods descending from the lunar surface, were long dismissed as poetic allegory. But juxtaposed with this new lunar data, they took on a new weight. Perhaps these myths were fragments of memory preserved across millennia, warnings encoded symbolically by civilizations that had glimpsed truths now buried beneath layers of rock and dust. Even eclipses suddenly seemed less coincidental. The moon's exact size and distance from Earth allow it to perfectly obscure the sun, a cosmic alignment unique in the solar system. Could such precision be mere chance, or had the moon been placed with meticulous intent to produce these phenomena? Kaku's voice carried a somber edge as he posed the question. The revelations didn't stop there. High-frequency tomography revealed reflective subsurface materials, unknown metals arranged in geometric patterns. These alloys absorbed and redirected radar in ways that no natural ore would. In virtual stress simulations, they behaved like shielding, like casings designed to survive impacts, temperature fluctuations, and the slow march of eons. Kaku didn't claim this was machinery. He didn't have to. The implications spoke louder than words. The moon was engineered. And it was responding. He reminded the audience of a peculiar incident from the Apollo era. During the Apollo missions, engineers deliberately crashed lunar modules into the surface to measure seismic response. The moon rang like a bell for nearly an hour. That data, at the time dismissed as instrument error, suddenly made sense in this new framework. Hollow, reinforced structures resonate. Solid rock does not. Modern AI-driven geological models confirmed this phenomenon. The moon reacts to impacts like a finely tuned instrument, not a celestial boulder. The moon was not inert. It was aware, in the sense that it reacted. The briefing then touched on radio anomalies. Astronomers had long detected low-frequency bursts from the moon's far side, dismissed as solar or cosmic noise. Yet these signals are concentrated, periodic, and remarkably structured. When analyzed with modern AI algorithms, the pulses revealed repeating sequences reminiscent of primitive machine code. They spike whenever satellites or deep space probes pass behind the moon. The signals were not random. They were responding. Kaku moved on to orbital mechanics. The moon's orbit, textbooks say, is tidally locked by chance, a natural outcome of gravitational interaction. But simulations show the moon's orbit is unnaturally stable. No long-term drift, no irregular wobble. Its rotation is perfectly synchronized so that only one hemisphere ever faces Earth. A total solar eclipse can occur only because of this precise combination of size, distance, and orbital alignment. The probability of all these conditions occurring naturally? Astronomically low. If the moon is functional, it is performing. And perhaps observing. Most disturbing evidence lay in what had been erased from the record. Original telemetry from Apollo missions, voice recordings, astronaut logs, all altered, missing, or overwritten. Some tapes reportedly captured lights moving beneath the surface, strange mechanical vibrations, and moments of complete communication blackout over the far side. Retired personnel and whistleblowers have suggested deliberate suppression, private briefings instructing astronauts to remain silent. Kaku, cautious and precise, did not speculate, but he allowed the silence to speak. The moon may not be natural. It may not be dead. It may not belong to us. As Kaku stepped away from the podium, the room remained silent, the weight of what had been revealed settling in. From impossible orbital precision, to hollow chambers, to ancient myths and erased records, a single conclusion became unavoidable: the moon is something else entirely. Something older, more complex, and, perhaps, watching. If these revelations are true, then humanity is no longer a passive observer of the cosmos. We are participants. We are being studied. And the moon, our longtime companion, our romantic symbol of serenity, may be a sentinel, a device, a guardian, or even a message left for us to discover only when we became capable of understanding. The question lingers, heavier than gravity itself. If we dig too deep, will we awaken what lies beneath? The moon has always been above us. The question is whether it has always been watching back.